Hello everyone, we at Shenzhen Jing Technology. This video continues the last introduction. If you want to increase the speed of laser engraving, we should set those parameters. One is speed, one is filling. One is the filling here. This filling affects the speed. The less content is filled, the faster the laser works. The smaller the spacing of the filling, the more content, and the slower the laser head. If the parameter setting padding number is too small, the display effect is not good. How can I increase the working speed if the number of padding parameters are set according to the best effect? We can increase the movement speed of the working head. Let's say I add it to 1200. What's the maximum speed? Speed within 1500 should not be a big problem. Mainly depends on the size of the QR code. The smaller the size of the QR code, the faster it works. There are 4 parameters that affect the engraving speed and the effect displayed by the QR code: working speed, number of fills, frequency, and pulse width. We mainly modify these parameters. These parameters are barely used, remaining the default. Default parameters are 0, 150, 150, 50. These parameters don't really matter. 50, 60, 80 are fine. The most direct impact on speed is: one is speed, one is filling, another is the size of the QR code. The impact of these 2 parameters is relatively small, mainly affecting the display effect. These 2 parameters should not be set very high, as running at maximum power for a long time will affect the lifespan of the laser head. As long as these 2 parameters are within 990 and the display effect can be satisfied, the smaller the parameters, the better. If the laser power of the machine decays in the future, we can increase these 2 parameters. For example, if we set 10 now, when the laser of the machine attenuates and the display effect is not good, we can set the parameter to 15. Engraved on the surface of white oil, the parameters are probably set between 10 and 15. General new machine depends on customer requirements. I usually go for a small setting. I'm sure not. I started with 30. Assuming that setting 10 meets the requirements, there is no need to set the power of the laser to the maximum. These 2 parameters, frequency and pulse width. This is how to make the content of the QR code template. My 4 times for QR code template is ready. Click Save. Let's give this QR code a name. Suppose it is a 18, then click Save. Then I'll click Save. After saving it, I turned it off, because I've done the program. Next step, I'm going to start programming. I'm going to create a recipe right here. Click New. Pop-up window. It lets you choose which template to use. Select the template you just made, and the more time goes by, the more templates there are. Normalized naming of QR code templates. This is the template you just opened. Templates, marks, placement coordinates from a program. If you have multiple templates, you can continue to add them. Supports multiple different QR code templates. After importing, we confirm the size of the PCB. Your width is 300. The length is 200 millimeters. Okay. This function is whether the machine needs to check the QR code after the machine engraves. We choose to check. It means that after the machine engraving is completed, the CCD immediately checks the results. The marking range in this area is also selected. This is to prevent secondary engraving. This means, after the PCB board comes in, first identify the marking point, and then identify whether there is a QR code in the area to be engraved. If there is a QR code in the engraved area, the machine will alarm. Click OK and the PCB will be sent out. If you are sure that there will be no engraved PCB board, you can choose not to. If you choose this function, you will have one more check time. We usually use these functions, and we choose this function. When all the parameters have been set, we will next click on this edit. Let's click Next to edit. Click to edit, and the machine starts to deliver PCB boards. We need to place the PCB board at the conveyor inlet of the machine. We placed the PCB board before clicking Edit. If you modify the program, you also need to prepare the PCB. After the PCB reaches the stop position, the next step is to capture the PCB image. Collect PCB pictures to facilitate the production process. The machine will capture images of the entire PCB. After the PCB image acquisition is completed. Next, make the anchor point of the mark. We recommend that customers place the first mark on the upper left or lower left of the PCB. The first mark is placed at the top left of the PCB, and the second mark is placed at the bottom right of the PCB. Top left, bottom right, or bottom left, top right. I click here directly, and the workhead will come over. You can also click Move, then click Move Window. Select a good mark as the anchor point. Move to the appropriate location and click Location 1. This will involve the brightness of the light. Some marks are not good, so I have to adjust the lights. After clicking on the light source, you need to know where these three lighting applications are located. The first light source is the brightness of the light source used by the machine when we made the QR code molding before. The second is the brightness of the light source used by the machine when setting the marking points. Identify mark points with two parameters. The third light source is the brightness used by the machine to read the QR code. These three sets of lights are actually the same light. It's just that in different application scenarios, it will choose different parameter values. This is the expansion. Adjust different parameters and check which one is better. Each parameter has a different effect. Different PCB materials use different parameters. All need to be debugged separately. Use different parameters to respond to products of different materials. We need to ensure that the mark is clearly distinguished from the surrounding areas, and the differentiation should be very clear. Because the materials of the products to be identified are different, it is necessary to choose the appropriate parameters. This has different light source parameters for you to choose from. After selecting the appropriate parameters, click Confirm. Then click Mark to locate one. Mark is provided with two templates. One is a shaped template and the other is a round template. Shaped templates include circles, rectangles, triangles, and other different shapes, while circle templates can only recognize circles. Commonly used is the shape template. Click on the shape template. We click on the top left of the target shape, release the mouse, and then click on the bottom right of the target. After clicking the first point, click the second point. Wrap the blue frame just right around the circle. Then we move the center of the blue box to the center of the circle. If the blue box doesn't stack with the center of the circle, or doesn't exactly wrap the circle, we can modify it. Adjust the position like this. We want to ensure that there are no marks of the same type nearby. If there are the same marks, the target may be misidentified. We're looking for a nearby area that doesn't have the same mark. The blue box needs to just wrap the circle like this. After wrapping the circle, then click the right mouse button. At this time, the window parameters will pop up. Adjust the contrast to make the target features more clearly visible. Moving to the right, it cannot recognize the features. We move to the left to reveal the feature points. You see it's a little bit red. But that's not enough. We're going to connect the red ones. Now there are more and more feature points. This place is almost connected in red. On its basis, the smaller ones between 10 and 20 have no impact. Machine recognition is mainly this circle. After the contrast is set, This is the threshold with the target reference. The marks I set now will be used as a reference when identifying marks on other PCBs in the future. Using the current mark as a reference standard, if the similarity reaches 90%, it means there is no problem. If the recognition rate is below 90%, the machine will sound an alarm. If the machine alarms frequently, we will set the parameters more leniently. Generally, setting 90% is no problem. This refers to the color for different PCB boards. PCBs of different colors have different recognition rates. If the recognition rate is low, we can adjust the light source to different colors. You can try different colored light sources to check the machine's recognition performance. But I use 3 channels more. 3 channels are automatically determined by the machine itself. This is the reference value for determination. This is the area of marks search. The machine is searching in the blue area marks. The mark can be automatically identified as long as it is within the search area. If there are similar marks next to it, we can narrow the search. The blue is the search range, and the red box is the mark. Modify these two parameters to debug the area size of the blue box. Finish, click OK. The first mark is completed like this. Mark 1 is displayed. A red mark will appear here. Next, I'll make a second mark in the diagonal direction. After clicking the Move button, we can click on the image to move. We chose a target as the second mark. You can choose different shapes as marks. Click on the second mark and select the shape template. Select the square as the mark. We use the same method to make the second mark. Debug the search range of marked points. If you debug the area of the search range very large, the first will affect the recognition time, and the second will be prone to errors. These parameters are set in the same way as the first mark. After we have set all these parameters, click OK. Click OK, so that the second mark is also made. Then click Move and select the location to be engraved. Click to move target location. Next, we place the template of the QR code in the position specified by the PCB for engraving. Place the QR code here, and the machine will engrave it in this location. Place the QR code here, and the machine will engrave it here. I put it here, and the machine will engrave the QR code here. You can place the QR code at any target location, and the machine will move to the location you specify for engraving. If you want to know the coordinates of where the QR code is placed, you can check here. The coordinates are displayed here, but the coordinate positions cannot be modified. After we move the QR code to the target location, the next step is to click Save. Hit Save and the program is done. If this PCB board is made up of many smaller PCB boards joined together, each PCB board needs to be engraved. How do I create the program? Select the target QR code and use an array method. We first select this QR code. Click the left mouse button to select this QR code. The blue shown here means the target has been selected. Then click on the array. We need to set the number of rows and columns and the spacing of the array. We set the number of panels to 2 rows and 9 columns. We engraved the QR code on these 2 rows of white oil. This is the direction of engraving the order of each puzzle. For example, 1 to 9, 10 to 18. The number of puzzles we engraved is 2 rows and 9 columns. The order of this engraving is different, which will also affect the speed of engraving the product. The order of the carvings depends mainly on the client's requirements. The shorter the distance the workhead moves, the shorter the carving time. The second option involves a shorter distance the workhead moves, resulting in a shorter engraving time. The same as the second option, there is also a fourth option. This method is mainly to shorten the distance moved by the working head. First and third, both start the carving from the same side, and we watch this sequence of symbols. Let's look at the meanings of these symbols, or we'll know their order once they're set up. Puzzle way set 2 rows 9 columns. We choose the second one and click OK. Next, we select the reference point spacing. Because we just entered 2 rows and 9 columns, there is no input spacing. We shall now set their distance. We should choose the same reference point. Just like a PCB pad, it serves as a reference point. I used this white oil horn as the first point. After clicking on the first point, we want to move to the last point in the column. Move the working head to the position where the mouse clicks. At this point, we click on point 2 at the same reference position. We have measured the total length, and the software will automatically cut it into 9 parts. Next, we need to measure the distance between the 2 rows of the puzzle. Then, at the same reference point position, we click another row of distance. After clicking Finish, the software automatically displays the location of the QR code. We only need to measure the total length in the column direction and the total length in the row direction of the puzzle. The software automatically divides 2 rows and 9 columns. Click Move to check. After checking that there are no problems, the program is completed. Click Save and give the program a name. Named according to the requirements of the product. You decide. If it is a standalone job, the work order number can be filled in at will. So I'm just going to type in the name here. Click OK, and the program will be done. At this moment, we can proceed directly to the engraving. If you are worried about a problem, you can check it out. We can check if the engraving position of the puzzle array we just had is suitable. In the recipe, click Edit and we'll check it out. The machine requires the PCB to be fed in. After the PCB comes in, the machine starts to recognize the marks. After the mark recognition is completed, all QR codes are displayed, and then we check the location of the QR code. If you want to change the location, select the QR code and use the WASD keys on your keyboard to fine-tune it, or you can use your mouse to click and move the QR code. Click this to check the second engraving position. If there is an offset problem, we select it and move it. If there is no problem, we click Continue to check the next one. Suppose we need to rotate the angle of the QR code, we click here to rotate the angle. If you need to debug to the specified angle, modify it here. Let's demonstrate. We click on the QR code and place it here. If there is another QR code, it needs to be engraved upside down. We select this QR code and rotate the angle. Rotate the angle you need. We have offset problems with all the positions that need to be engraved, and check that there is no problem. Click Save. Now you can start engraving the QR code. Let's click on the green Start button to start sculpting. The machine alarm is that this installation door is not closed. If the safety door is not closed, the machine cannot operate. In order to prevent safety issues, any part of the body is prohibited from penetrating the machine during operation. This safety door lock must be closed. I am now entering the program. We also need to set the brightness of the light source for the machine to recognize the QR code. Click on the light source to debug the brightness of the identification QR code. This is the brightness when the debugging machine recognizes the QR code. After debugging is complete, click OK. Click Save. If the light source is too bright, the machine cannot recognize the QR code. Click Start, and the machine starts to engrave. The machine starts carving in this order. The machine recognizes the marks. After identifying the 2 marks, start engraving the QR code. The machine will engrave the QR code while using the camera to recognize the content of the QR code. This is in progress at the same time. If the machine cannot recognize the QR code, the machine stops. Well, the machine has finished engraving the QR code. After engraving is completed, it is transported to the exit location. This is the QR code we engraved. The number of puzzles is 2 rows and 9 columns. This is the complete programming method. Okay, let's click the machine to stop.